Hey, okay, tonight we are going to start working on a project that we actually started this morning working in our Zoom meeting. And just in case you didn't catch that, if you didn't make it for that, we're going to go ahead and go back through. But here's the part that we did. This is not going to be the assignment. This just gets you ready to be kind of walked through and gets you to help understand what it is that we are doing in Machining 134, which is our CAM class. And so computer aided manufacturing is what we're doing. It's MACH 134. And so today's Monday 6/8, and this is our project. And so it's just a little cube, or not really a cube, it's really a square stock. It's 2 inches square, and it's an inch thick when it finishes. It's got a little kind of a square racetrack that goes around it. Inside of it, you can see it up here in the isometric. It's got a half 13 tap that goes through it, and what you see here is just a couple of examples of just the description that I put out for just this morning. Throughout our time, we'll learn how to also not only make the drawing, make the parts, do the machining for it, how to make the template to make this whole section and all this stuff work out together all at one time, how to look good. Here's our part that we're making. I'll run through a quick graphics of it and we'll see what it looks like. And let's see, so here's the part that we're going to make. Well, all we're machining is the top side of it. X0, Y0, Z0, datum is down here. We'll do a quick run through graphically. That's our part. So I know that you wish that parts would run that fast for you. You also wish that they would program that fast, but they don't. That's okay. So if you have done anything in Inventor, or maybe HSM, or Inventor and HSM, or maybe used another CAM system before, these things are going to be pretty straightforward for you. I've added a couple of different things to this one just to kind of help it clear out a couple things, do a couple things just to make the program just a little bit cleaner. One of those things is this second contour. So what I've done here is I come in with 3-inch face mill, I face mill it. Then I use an adaptive pattern for the inside. Then I use an internal and external contour where I hit both inside edge and then outside edge. But it leaves some little areas. But even though in adaptive I went down all the way down to the bottom, I thought, well, I'll just go ahead and run a shot through the middle of that part. And so that's where this second contour comes from. Then I went to hole recognition, and hole recognition allowed me to go ahead and do the countersink, drill, and tap basically all in one shot. So one button click by using hole recognition for that. If you don't have hole recognition on your Fusion 360, so if your toolbar up here, if your ribbon at the top doesn't quite look like mine, if you go in here to basically your tools, you go into all of your extensions, and I don't mean tools like cutting tools, I mean all of your Fusion 360 tools. So all of your extensions, you go in and you can kind of pick what you want, anything from additive manufacturing, 5-axis, here's hole recognition. You got probing geometry, so you can do some of your probing stuff there. You've got a lot of different things there. And you can add in all of those things. I've already got all of them added in. So, and if you're in the EDU package, then you should be able to add those things in. Zero cost. They do have a time frame that they run on. But after that time frame expires, so 30 days, 90 days, I can't remember what it is, you can go in and just restart that, and it'll go right back to normal. So that's just a little bit, kind of a really, really, really high view of what Fusion 360 is. So let's do this. Let's get started with our part today. And so I want to have this drawing up so that I can see it. So I'm going to go ahead and flip over to it, and then I'm going to just do a quick output as a PDF. I'm going to save it on my other screen. Just put it on my desktop, and that way I can see it while we're working on it. And because I'm going to close these and then just start from scratch. Okay, so when you start Fusion 360, you should come up with something like this. It may have something on the side, it may not. If it doesn't and it just looks like this, if you'll come over and let me stretch my screen out a little bit more. There's a little nine boxed cube, if you want to call it that, that'll allow you to expand. And yours might look something a little bit more like this. I've created some parts and some folders for a tool library, and that's where I come in and I can find these. And I cannot tell you enough how important it is to have good file management. And so what I do is I have a folder called Justin State Fair Community College Project Library, and it holds really every single thing that we are currently working on in here. And that's anywhere from this 5-axis project, our 5-axis trunnion altogether. Anything that's in our CTC that we're working on right now, some drawing templates, stuff for the robots, just general projects, Jingle on the Green, and then just class projects. And so we're in MACH134, so everything that I make in this class I'll be putting in here. And so I'll have kind of a project folder when I get done, even inside of 134, where so maybe today we've called this the MACH 134 sample Monday 6/8, and then that folder will be named inside of there. So just like if we're doing handwritten programs, same situation. You cannot manage your files too well, and so just really want to encourage you guys to go ahead and start creating those files so that you know what you've got and you know where to find it quickly. It'll pay off dividends in the end. It'll make life just a lot easier, a lot less complicated. Okay, so enough chit chat. We'll get started. I'm typically drawing stuff in the morning. Today I am not. I'm on the downhill side of the day, so hopefully I would love to think that I'm sharper, but I'm probably not. So what I'm going to do is I'm going to be in the design phase. So I'm going to come in here and I've got some options. I got 4, 5, 7 options that I can choose from here. I'm going into design, and I'm going to just start really kind of from left to right as far as I go, and I won't even need to go all the way down here. We'll not cover all these as we go. Some of that's covered in immersive, and then the rest of it we can just work through it as we go. We're going to probably not go any further than about to this little fillet area here today. Probably won't even go that far. So what I'm going to do is I'm going to start here, and I need to make some decisions where I want X, Y, and Z to start from, how I want them to move. So even though I've got my grid here, I'm going to go on up to the upper right hand corner where I've got my isometric view. I'm going to go ahead and click on the top. That's going to change my orientation, and then I'm going to hit this box here. Just single click on that. That really begins my my drawing. And the reason that I picked it in that square is really I want to keep in my mindset that this lower right hand or lower left hand corner will be my 0, 0. So I'll still need to pick that later on, so it won't take out a step, but it does help me to kind of set things up. So when I draw my first square for it to get ready to make my parts, because I can start drawing lines here. Here I'm going to come in. I'm going to click this. This is the second tab over. It looks like a rectangle. It's got an upper and a lower corner highlighted. I'm going to come in here and hit the datum at 0 and start stretching out. I can make a square or a rectangle, whatever I want it to do. I want this thing to be 2 by 2, so I'm going to hit 2 and then tab and then 2 again. That creates my square. So we had said that our customer sends us a blank that it is 2 inch by 2 inch, so 2 inch square stock. And let's just assume that they're sending us 2 by 2 blanks, and they're a 1/16 over an inch. So just to give us a little bit to take off that top side. So let's just assume that the bottom side's finished. All the sides, the four sides around the part, we're going to drop this into a fixture, into a vise, into something. And all we're going to do is face mill the top side, run that racetrack down inside of there, drill and tap that hole all the way through. So we've got our stock. From this point on, I'm just going to hit finish sketch. Now, all it's created was a box, okay? So it's just square is all that it is. So what I'm going to do is I'm going to go ahead and move over from left to right. I'm going to go ahead and go to an extrusion. And I'm going to extrude it a -1 inch because I want it to go downward. And so there I am, moving down. And then I'm just going to hit OK. And so I've got this nice blue box. I created it to be that color. All of my aluminum parts are this blue. No real reason other than personal preference. I've got some other parts that are green. I've got some parts that are kind of stipply looking. I've got several different ones that just look different ways. So at this point, I've already got some stuff on here. Now what I want to do is I want to go ahead and save. And so I'm going to go up to my little disk, and I'm going to start setting up where I'm going to save this thing at and what I'm going to save it as. So it's going to automatically go to my folder that I created, Justin State Fair Community College Project Library. And what I'm going to do is I'm going to go into 134. And so I've already got some stuff set up here. So I'm actually just going to make a whole new folder. And it's going to be MACH134. And we called this Sample Monday 6/8. I'll respell Monday. Okay, and then save. Oh, it's the slash has got me. Okay. Let's do this. Let's go back to new folder, and we're gonna go MACH134 Sample Monday, and we'll go 6_8. See if it'll take that. There we go. So it won't take the slash, but it will take the underscore. Okay, so I go in, I find my folder. There's my folder. So I've got already for this semester, I've got a little puzzle project for us. I've got a depth stand, and then here is today. So this is where I'm going to put it. And I'm going to call it my Machining 134 Sample Monday 6/8 drawing, and I'm going to save. So Fusion does a pretty good job of doing some automatic saving for me, and also having the ability to do some recovery. From this point on, whenever I want to save, I can just go in and do a save as, and if I want to move it, file locations, I can. I would not recommend doing that. And here's why. I would try to keep all of my Fusion stuff in Fusion, not on my desktop. And the reason why is because if you're creating files at home and then you go to the shop and you're ready to run a part, but you saved your latest version on your desktop at home, and you don't have that with you on a USB, or you didn't bring your laptop with you, you're gonna have a little bit harder trouble, or a little bit harder time recovering that file. You still will be able to do it, but so Fusion works in the cloud, and I would just suggest that you stay in the cloud. So here I've got my box. Now I need to go ahead and put my racetrack around the outside of it. I'm going to bring over this other screen here. So we've got this square so far. We're going to go ahead and make this track around the outside, or around the inside of it. And I haven't dimensioned that out yet, and I don't even know that I really have any kind of dimensions for it. That's the thing about a widget, is you kind of just have the ability to play with whatever it is that you want. Your project that I'll give you guys will have some more defined dimensions on it. Okay, so not to get ahead of myself, I'm just going to go ahead and start with a new drawing, or a new a new drawing that goes inside of this. And so I go again from left to right, and I just start here and get it going. I'm going to go ahead and go back to my rectangle command, my rectangle square command, and all I want to do is just put something on here. And if I can get really close, I can. That's awesome. If I'm not, I will be able to move it around. Fusion has a really sweet way to move things around. So I've got an 1.5 by 1.5 square. Hit OK. Zoom that in just a little bit. Pan it down. So the opened hand is for panning. And then I can fit. So I go down here and I can go fit, or I can zoom window. I can do some orbiting if I want to. Here I can do a couple other things. I can turn the grid on, turn the grid off. Just really do a lot of things to make my life just easier. All of those things are really what we would call preference issues. So just how you prefer to use those parts. Okay, I'm going over here to my dimension. Just looks like some leader lines or some dimension lines. So I'm going to click on a reference line, which will be this outside edge. Click on this next edge, and let's go 0.25. I think that'll put me in the middle, yeah. And then I'm going to do the same thing up here, and 0.25 should put my square in the middle. Okay. Now I'm going to put another square inside of there. Alright, so let's say that square is going to be 1 by 1. Let's see, so that puts my inside track at 1/4 of an inch. So yeah, that'll be okay. There's a couple things I don't love about that because of my end mill choice, but I think that'll be okay. We'll just stick with some nominal stuff here. It's not like we always get to choose what the customer wants. So from here, I'll just click over here, get my dimension, and I'll go 0.25. And then from here to here, I'm going to go again 0.25. So now I've got essentially a box with just 2 squares on top of it, and I need to get those squares. I need to put some radiuses in those corners. Radiuses are 150 thousandths radius typical. So again, working from left to right, I'm going to go over to my radius command, and I'm going to click on it, and I'm going to hit 0.15. Now I'm going to leave that command active, and I'm going to go ahead and just start clicking all the corners that I want to go. Uh-oh. I missed one, didn't I? I'm off an edge, so I'm going to go ahead and go back here and re-click. Come in here first. Here we go. Pull it in a little tighter. Okay. 0.15. Again. 0.15. And again, 0.15. Okay, so I'm done there. I think I have all of my radiuses set here for 0.15, and I will finish the sketch. So as of now, I've got 2 sketches on there, so I can go in and take a look at those that I've got. Sketch 1, sketch 2. Here's another really cool thing that's happening as you're doing this. You're kind of building here at the bottom, on this bottom ribbon, you're building kind of a timeline. You're building exactly a timeline of the part that it is that you're making. So here's the original cube, here's the extrusion, here's our second sketch that we made. Now, so I want to go again left to right. I'll go ahead and extrude my tray down right here. Fusion's really good about kind of picking up some stuff. Go from here. It's automatic mode is to go up. So let's just try that. So let's say we want to go. It's going to be 100 thousandths. If we pick it as default, it's going to go up and make like 100 thousandths boss that goes around the outside of it. It's pretty cool, but it's not what we want. So we're going to go down to cut, and we're going to go minus 100, and we got this tray now created inside of there. Okay. So I'm going to hit OK. I'm going to go up and I'm going to do a quick save. Now, what I kind of love and hate about this, I'm going to go ahead and open up this folder that I've got down here. Here it is up here. It is consistently creating as I make saves to my part. If you'll notice up here, it says version 2. Now I can see the details of what that is. This is where I made it, and this is then my newest version of it. So I get a lot of information about what's going on. What I don't love about it is just personal preference that if I go in and change any single thing on it, it creates a new revision. Now, long term, that's great for us. That's just in my own mind. It looks like I have drawings that they are version 21, they are version 35. Just maybe because I went in there and added some assembly parts to it or some other things like that, and just in my mind it makes it look like I'm indecisive or I've changed my mind so many times about it. Anyways, like I say, that's personal preference. Okay, so I've got my part here again. I'm going to go ahead and create my tapped hole in the middle. That's really the only thing that I have left to do on this part. So I'm going to go to hole, and I'm going to go right into the middle of it, and I'm going to center it up. So I don't know that that's totally in the middle. It's definitely not in the middle. So I'm going to go over here, and I'm going to hit reference. So I go to select. I'm going to select an edge. For me, I know this part's 2 by 2, so I'm going to go 1 inch, and then I'm going to select another edge. I'm going to go over here to this edge, and I'm going to hit 1 inch. That centers up my part, or it should anyways. Yeah, looks pretty centered up. So now while I've got it here, I'm going to go ahead and choose what I want my hole to look like. So you get a little buffet menu here of what you want it to look like. Do you want it to have a chamfer? Do you not want it to have a chamfer? Just a hole with a counter bore. We want a hole with a chamfer. We want our hole to go all the way through. So it could be partially bored, partially tapped. It could be tapped all the way through. Could be tapered. We want to go through with our tapping. And we're not concerned about drill point because we're going to go all the way through it. So here is what we're going to do. So sorry, I got to get back over to threads. I'm talking and not paying attention to what I'm doing. So I'm going to change my depth to 1 inch, make sure that I go all the way through. You can see the arrow. So this is all real-time live. It's pretty slick. So that arrow put my hole all the way through. Now, why is my hole so small? Well, my hole's so small because that's currently what I've told it to be. Look at what it is. It's a 256, so it's an 86 thousandths number 2 drill. It's pretty deep to go with that. It's not what we want anyways. Do we want a 90-degree chamfer? We want 90-degree chamfer, and we're going to bring it out to 520. Again, made this huge cone. Looks like a big old funnel. So now we're going to go in here and change what do we want our threads to be. We can be metric, American Standard, and that's what we want as American Standard. We're going to go into our hole size, and we're going to pick a 1/2 inch. Now here's what I think is crazy about Fusion is, and maybe it's just where I'm at in the world. I've never in my life created a 1/2-12 thread, and it always defaults. I mean, it's defaulting down to the low options, right? So I mean that makes sense, but like I wish it would just go down to like the most common one. So same thing for class of fit. We automatically go to 1. So anything that's internal is going to be in the B's, anything that's external is in the A's, and our direction is right-handed. So you can either model your threads now or not. So it doesn't really make a difference here for what we're doing today. If I am on the lathe side of things, if I'm turning these threads, whether I model them or not is going to start to make a difference. If I were to 3D print this, whether I model the threads or not makes a difference. So if I'm 3D printing, so if I'm using the additive stuff that was up here in that in those extensions, if I choose to do some 3D printing in Fusion, which is awesome and it's really great, it goes into anything that you're using, Eiger or whatever it might happen to be. Modeling your threads makes them turn out a lot better. You can get threads from non-modeled threads, but this is really how you make good threads. Okay, so enough about that box. We've got that taken care of, and now we've created a hole that goes all the way through. So it's slick. And again, we're adding to our timeline down here. Now, if we look here and we're like, oh my gosh, I forgot to do this, or I did this, I changed this, I can go back in my timeline and go ahead and make some changes to it. If I need to go back into a sketch, I can go into sketch 1 or 2 and make some changes in it. So while we're here, another command that I use a lot in this area would be just this radius chamfer section, where I can create fillets or radiuses around my parts. Typically I'll come down here and start it from here. I maybe do a chamfer around my part. I might click on this edge and then just hit 50 thousandths, and then I've got that edge. Now my timeline is showing it. Now if I decide I don't want it in there, it's gone. I don't want it in there. So if I were to do anything, I might do like a 5 thousandths, really small one around there, because I'm already going to use a spot drill. So I could do that, but again, it is now 9 o'clock, and I don't think that's on the docket for the day. So I'm going to roll myself back around, get myself straightened back up. From this point, I could go ahead and I kind of go 2 different paths. I've got my drawing made. I'm going to do a quick save. So that should be now version 3. Give it just a second to catch up. So from here, I want to just make sure that I'm happy with what I got, and then I come back up here. So all my drawing, my actual drawing of my model is completed from this point. Shouldn't have to go back in and change anything there unless we make a change. Another thing that's really sweet about Fusion is it is pretty adaptive as you go through. If you make a change to a depth, a diameter, dimension, you're gonna see that sort of follow through. And if you can keep all of your stuff in one program, if you keep your drawing in Fusion, your cam in Fusion, your code in Fusion, it comes back to file management, and it's just a better, safer, easier place to find everything. And let that stuff change altogether. Your setup sheet will change, all those things that'll go with it, and then you'll be in a lot better spot. I'm going to go quickly into the drawing side of things. So I go all the way down here to drawing. I'm going to go drawing from a design. We just created a design. We are going to go from, I already have a template created, and so we're going to use that template. I'm just going to hit OK. I'm just going to make a really, really, really quick drawing on this thing. Okay, so it is Machine 134 sample Monday 6/8 drawing, and so I don't want my front showing first. I'm going to go my top, and my scale I don't need 1 to 2. I want 1 to 1, and so I'm going to set my part right here, and I'm going to hit OK, and from there I'm going to start to make, or actually I am going to make a side view and then an isometric view. So there's my top view, and then now I'm going to make a side view of it. And because of the way that this part's made, I don't need 3 views. I don't need a front top and a right side. If I see this top, and then I get this side, and I should be able to make the part from it. One thing I will do is I will create an isometric view from it, just so my operator, my programmer, whoever it is, can see that and be able to make their parts from it. Just get a better visual representation of it. Something like this is cheap and easy to do. It takes a little bit of ink, no big deal. So I'm going to go ahead and place it there, hit OK. Now, that's an OK drawing right there. It's not bad. But whenever I have the option, I'm probably going to come in and hit Edit View. And I'm going to go in and I'm just going to create that thing as a solid. Just solid in color, just so I can see that better. Now, if I'm printing out black and white, or if my printer just is junk, then it prints this out as a blob. Then obviously I'm not going to do that. But if I've got something that's laser, or something that comes out nice, then I'm gonna do that. Just so my programmer, operator, setup guy, whoever, who just has all the information that they need. One of the really cool things that Fusion has is the ability to add sheets. Really simple. Just add this plus. You can get more sheets on there, so you can put as many sheets as you want. Your revisions come along pretty easily too, and so we'll talk about that as we kind of continue on through here. Creating the drawing or the print isn't such what I'm concerned about today. I'm just kind of showing you through some of these things. What I'm concerned about is you having the ability to build the program for it. So we'll throw in just a couple dimensions, 2 inch by 1 inch. So pet peeve of mine is that Fusion does not do some automatic hole recognizing for being a tapped hole like HSM will do. So what happens is you end up doing a leader and writing down here all of my tap info. And I am always just a little frustrated by that. Okay, so whatever, personal preference again. These programs can't do everything for you, but they sure do a lot. So I'm going to save that. It's a drawing, so it's going to be stored together, but just with it, but it'll be it's a separate thing inside of there. So I go back to my my model here, my sketch and my model. So I'm going to go ahead and come in and start getting ready to do some machining on this thing. Okay, so if I go back from design and I go to manufacture. Now, what I want to do, again, I'm almost always moving left to right as I move across this thing. So I'm going to go ahead and create a setup for it. It's going to do what it thinks is best, or what it kind of anticipates you doing. I'm going to move this out of the way. And so it creates a box. Kind of reminds me of a superhero in a green screen movie when they show kind of the behind the scenes stuff. So I can pick from here if I want to. Fusion likes me to check all the boxes and fill in all the blanks as it goes, and that's fine. I have a Haas set up with AB on it, and it is, I shouldn't say I have a Haas set up on it like that, because I've really just got this blank one thrown up here. It's not always the one that I use. I have some better post-process library stuff and machines, but this one's here and available, so I'll use it for right now. It'll do everything that we need to. Our operation could be milling, turn miller, cutting, additive. So we're going to be milling when we're on the lathe. We're going to be turning, and then fourth and fifth axis would be doing that as well. If I'm doing a plasma cutter, I can do cutting. If I'm doing 3D printing, I can do additive. So my origin is going to be from a selected point, and it's going to be down here at this baby. So I'm going to zoom in, make sure that I've got it where I want it. One of the mistakes I see people do is that they click on something and it's not quite there, and they end up clicking here. They end up clicking close to it, but not it. So that's where my X0, Y0, Z0 is going to sit. Now I'm going to go over to stock, and I'm going to clean it up just a little bit to take out some of those scenarios. So I've said my stock side offset is 0. So customer sent me a block that was 2 by 2, and I said earlier that they sent me is a 16th over, so we're going to say 62.5 thousandths oversize. You can see that added to the top of the part. There's no bottom offset, and there's no need to round to the nearest anything, because rounding is stupid. So if I want to, I can go ahead and come over here. I can go ahead and name my program, or number my program, sorry, 2525. I can put any kind of program comment in there. Oops, doesn't need to be in parentheses. It'll create it in parentheses. We can just say sample and PLE. Okay. WS, this is going to be our work coordinate system offset. If I choose 0 is G54, 1 is G55, 2 is G56, you can see where I'm going. Multiple work offsets means that I've got multiple work offsets. So maybe I've got something with a B axis, maybe I've got a horizontal with multi offsets. Maybe I've got a 5 axis, whatever. It's on a tombstones on a pallet, tool changer, whatever it might happen to be. It's something that needs some additional offsets. I can have that option there. So from this point, hit OK. Now, one thing that I like to do, and I like to do it early on, is I like to go in and do some changing of names. So let's just call this, I'm just going to say it's a vice setup, just to give my operator a little notice. I did not do that when we did the Zoom. I think I just called it one and only setup. But so we just call it vice setup. So here my description becomes vice setup. Helps to just give me a little bit of clarification about what's going to happen and what I'm doing. So I'm putting either this in a vice. I can put some more information on there about how the operator is going to set that up. I can do that in the setup sheet too as well. Setup sheets over here under actions, third tab over. So first thing I'm going to do, again, working left to right, is I'm going to go ahead and do my face milling. Now, here's where you and I are going to have a couple of different, or I will have an advantage, you'll have a disadvantage. I've already got tool libraries made up. We're going to make some tool libraries up as we go. I'm also going to tell you how to just kind of add in and load up some that are going to be free and easy for you to use. I would always encourage you to copy and paste rather than to create your own. And why I'd say that is because a lot of times the graphics are just a lot better in the ones that you can just grab from something else. So I'm going to go to my tool. Now, whenever I come up, mine looks like this. It has a cloud, it has local, it has vendors. So let's see, I could compress that. It might look, yours might look like that even. So here's what you're working on. It's going to build a tool list for that. I have a cloud set up that has all of my SFCC tools. So I've already created a pretty healthy tool library. It's got anything from, this was one that we created earlier. I'm going to delete it out because it's stupid. All we were using it for was to just change some other things around, just to show some ideas of how to do things. So I've got a 6mm probe there for, it's a Renishaw probe. And then I go to my 3-inch Kennametal shell mill. So here's one of the reasons why I would have you, or I did have you, download Novo in the beginning. Novo is Kennametal's software, and it has all of their information about all of their tools, so you can put in the tool number and it's going to tell you everything you need to know about every single tool, so you can get all your tool data off there. What you can't do is you can't just take a Novo file and then load it right into Fusion, which would be awesome. But our awesome friends over at Titans of CNC have already created a whole bunch of stuff over there for you. So go over there, sign up for Titans of CNC, the Academy. It's free. And then you can come in and download all the tool packages that they have. Don't go berserk and load up things that you know you'll never use, because too much stuff is too much stuff and it gets complicated. It's like when your garage has too much stuff or your closet has too many clothes in it. You only wear 3 shirts, so just don't have 10,000 things in there. So I'm going to pick my 3-inch shell mill. Okay, so what do you do if you don't have a 3-inch shell mill? Great question. So I can do a couple of things. I can go into my samples. My samples has like an insane list of holders in there. I can start to work those things down as far as what do I want. I want aluminum, I want no aluminum, I want certain kind of holders for certain types of tools. It's got turning tools, it's got milling tools, it's got every single thing in the world that you can possibly imagine. So I can search through all of those, or I can go to operation. I can go to a facing operation, hit OK. It's going to start to narrow down some of my stuff, and then I can go down to, what do I want to do? Something like, I don't want to do that, I don't want to do that, but I want to face mill. Oh, so I'm out of options there. So let's go back and just in here, let's go back just one step, and let's go get this out of the way. It's not going to help me at all. Okay. So here I took aluminum off the table, and I have a 2-inch face mill already set up, just kind of a generic sucker. If I prefer to be metric, then I can go in and use the metric choice in there. So here's what I'm going to do. I am going to copy this tool. I'm going to create a new, or actually I guess I could just come up in here. It's going to save all my information in there. And then I'm going to paste that tool in there. Our 3-inch shell mill, it's 3 inches, not 2 inches. So you could use a 2-incher here, but we have 2-inchers, but we're going to make it a 3-incher. So I'm going to edit this tool. So I'm going to call it 3-inch face mill. And I'm going to change it to a Metal. And I don't know the number off the top of my head. I'm not there today. So I'm just going to jump over to this next tab to my cutter information. It's a face mill. It looks very similar to what ours is. I'm going to go into a 3-inch, and so you can see all that stuff's changing as I go. Flute length is pretty close. I think ours is 620. Material is not high speed, but it is carbide. No through coolant. Clockwise, it is 5 inserts. All the other information is pretty insignificant to us today. Feeds and speeds. So here's what's cool. I can either go by RPM. So if I wanted to go 8,000, if you look at that, it changes the surface speed. Sorry. If I want to go by surface speed and say I want to go 5,000, it changes my RPM. So one can be even and one can be odd, and you'll probably hardly ever make them both the same. Same thing with my feed per tooth. I usually want to go a little bit faster with that, so I change my feed per tooth. So I'm going to cut at 162 inches a minute. If I want that to be 150 or 160, whatever happens to be, it changes my chip load on there. So 4.6. So whichever way I'm more anal at. So then post processor. This can be tool number 1. It can be tool number 2. So let's just make it tool number 2. Let's just assume we have a probe stuck in there. The only other thing that I think I need to put here is I could put some type of comment if I want, but the only thing I really need to put is make sure you put a live tool. If you do not put it in as a live tool, it will not turn the spindle on, and so like a lathe tool would not be a live tool. So other than that, we are good to go. So now we have our 3-inch face mill, and so that's all we have set up in this library. But here's one thing that's really cool is every time that you make a project, you're adding to your tool library. So it's just like in your toolbox. Every time you buy something, stick it in there, then you do not have to borrow it anymore. So you used to have 6-inch calipers, and then everything you needed to measure was 7-inch, and then so you bought some 8s or some 12s. Then you never had to borrow calipers from anybody until you ran into something 16 inches, and then you just have them. And so building a tool library is the exact same way. So I've got my face mill. I'm going to use it, and I'm going to face it. So I've already put in all this information. I've already taken care of all this data. Now the only thing that I really want to do is if I want to do a pass extension of maybe 1.6 just to get it beyond the part. I don't have to do that, but I can. Fusion would not do that by default, but if you just want to force that, you sure can. That's not a problem. So our contour that we're going to select, we need to select that. It's going to be down on this line right here. So we're going to select that boundary. That's going to be our chain that we're going to use. The rest of this, zoom out. It's going to be our clearance heights, and as we come down and start up our program, we're going to come down, wrap it here. So looking for clearance planes, and then you can adjust these as you want. For this, like like I love to tweak some things, but at the same time, man, you can spend a lot of time jacking with stuff that really has absolutely no purpose other than just this personal preference. And honestly, I tell you now, um, excuse me, get over some of those personal preferences because they really just add a ton of extra time to the stuff that you're doing. So from here on out, I think I'm in pretty good shape. Um, okay, so there is my face milling. Actually, I was wondering where it went there for a second. So let's just run that through. Go up here to simulation, and I'm just going to run it out. There I am. I'm down to 0. Looks like a champ. It looks like green. I don't know. Sherbert. I guess it looks like plastic vinyl is what it looks like. So don't get caught up too much on doing that. You can only watch it simulate so many times. And so face milling's done. We've made a lot of progress. We've actually created a drawing. We created our model. We've got a ton of stuff here in a short amount of time. We're 45 minutes in. We've done a lot of work in just this time. And so now I need to come in and keep moving. I need to do a new pass here, and so I can come in and do a couple of different options. I've got some pocketing, some adaptive stuff, and I think before I picked, gosh, if I can remember right, I think I picked 2D pocket. It defaulted to my face mill again. Not going to be a good choice. So I'm going to come in, and I think I did not have an 1/8 inch end mill set up. Or let's see, the slot is a 1/4 inch wide, so I'm going to cut it with this with an 1/8 inch end mill. I have 2 of these number 5s. I'm going to go in and edit this guy. And I'll leave it as number 5, but I'm going to go ahead and change its description and make it an 1/8 inch end mill. I've got a note on there that it uses G41 cutter compensation. Change the diameter of it to 0.125. Let's say it's got, that would probably be too many. Let's say it's got 3 flutes on it. And we're going to say that it's carbide. Side note, just as we're looking through this, that's probably okay. Let's go chip low. Let's move it down just a little bit lower to 2000s. When it's adaptive, it's not gonna, it's gonna change the way it cuts. And if you're not familiar with it, you'll see it here in just a second. So we're gonna make the description 1/8 inch, and it is 3 flute. We don't want our operator to spend 30 minutes trying to figure out what tool it is, only to find out that the description's wrong. 1/8 inch flat end mill. Okay. And so we hit OK. And so now we are going to come in. We've got those things set because we already did that. Pocket selection is right here. And let's see, we move on over. Those things are fine. Stock to leave. Let's leave 10 thousandths on the side walls. Let's leave 0 on the bottom. We're going to do climb milling, and there's really not a ton more options other than some finished passes, and I can force some directions, but I don't want to. I can also force multiple step downs. I'm not going to. But I could. You got a ton of options as far as how you go in, how you move. If I want to do some, like the only thing I think that I would probably do is do, maybe some step downs on this part. And gosh, I don't know that I even will on this. We'll tackle those as we go. Just getting this far is going to be pretty solid for us today. So, now how we chose to go in here isn't really my favorite, but I'm okay with it. Again, sometimes you have to kind of just live with what your cam creates for you. It's slightly different. This is a little bit different choice from what I picked before this morning when we were doing it in Zoom. why it chose or chooses to go down in 4 paths or modes is to clear out this little island that gets left into it. Okay, so let's run a quick graphics from, we'll run a simulation from the beginning. Stop that guy and then go simulation, and we'll go through at top speed. Going in, oh, sorry, I didn't pick it from the beginning. Let's go top speed now. Okay, so got a pretty slick little racetrack in there, and you can see I've got side area uncut. That's what I want. I want to come in and I want to be able to take a finish pass in there. So I'm gonna go ahead and hit save that guy, because it's my luck that something, power goes out or something happens. Wouldn't be a big deal on this part. I've drawn it 9 times today, I feel like. So we got version 4 now. Same min mill, but I want to go in and I want to do a contour. My contouring, so again, left to right. So I've done a face mill, a pocket, and then now a contour. Same tool, so it defaults to the last tool that I use, which works awesome for this one. I can use that, or I can pick another tool. So I'm gonna pick the bottom areas of the area that I want to hit. So if I hit here, it's not going to go down here. It's going to go up here. So I need to hit down, and then I need to move around, and then I need to hit down there. And what is super slick about this, it automatically knows I'm on the inside and the outside, so it's going to cut on the left-hand side. So again, here I've got just my clearance heights, and I already have all my speeds and feed calculations information set in there over here. So I don't think anything else I need to worry about in here. I hit OK. Take care of my inside and my outside. So it's going to do a quick shot in. Let's go back up to here, and we'll run. Sorry. Let's go back up to here, and then we'll run it from there. Again, higher speed, just so we can move through it. Face mill, pockets, racetrack, there we go. And so that turns out really, really slick. Now, I talked about and did before, what you will have is in some small areas, you'll have these little bits that didn't get hit by that second end mill. So let's just take a look at what those would look like. Okay, so see those 4 chunks are left there. Now they were taken out by the pocketing, but you have the potential to have a little raised area right there, just if you're using 2 different tools and they're not hit on the same depth. Now we are using the same tool. We roughed and finished. We did the pocket. We roughed the pocket out and we finished the pocket with the same tool. But if I want to fix that, I'm going to come in here and I'm going to just duplicate this. I'm going to hit save one more time real quick. Okay, so I'm just going to call this my mid pass. I'm going to open it up. I'm going to deselect my chain, and I'm going to just check one of them. Now what it's going to do is it would just cut one more shot through there. And so what I can do is I can come in, and if I can remember where it's at, I can go into stock to leave. I don't want to leave anything on the bottom, but let's just say I want to leave 1/8 of an inch. Should put me somewhere in the middle. Yeah, it's a little bit towards the outside, so let's go back in there and edit that. Let's say maybe 100 thousandths. Actually, probably 60. That's 620. So let's look at 60,000. Okay, looks like that's pretty much in the middle of my part now. So I got a pretty good chance now of that taking care of those little islands that get left now. We'll do a super quick save, hopefully. And then let's just go ahead and run. We'll run these last two passes, just see what they look like. So a big old shot through the middle there. And then this guy would take a remainder of it out. And it's kind of hard to see there. This is the entrance and exit of it. It spirals in and out, but it still stays within the boundary. See? So, like if I was using this as a tool 6 and tool 7, I'm sorry, if I was using this as a tool 6 and then these two as tool 7s, I might do something like this. If I'm doing it the way I'm doing it now with tool 5, I'd probably leave it alone. So here takes care of this. The only thing that we have left to do is tap the hole in the middle. Let's see what that thing's going to look like. And so here's what I'm going to do is I'm going to go ahead and use my hole recognition, and then after that I'll go ahead and show you how to do it just as kind of a manual operations, just in case you don't have this. Okay, so I'm going to come in here and it's going to ask me what I want to use or what I'm trying to do. Again, Fusion's really good about just helping you make some decisions. Super intuitive. So it knows that I've got some stuff happening here. I'm going to go ahead and change this to through hole. It's going to be half 13, and it shows that it recognized one hole, and it's going to pull from my existing tool library to take care of those other things. If you don't have that, you're going to make those. Okay, so you're going to make a half 13 tap. You're going to make a spot drill. You're going to make a 27/64 drill. So needs just a second to generate. You can see it down at the bottom. It says gathering tools. Super awesome for you. Boom, done. So hopefully my hole tapped all the way through. It sure darn looks like it does, doesn't it? So that then shows tool 1, 2, and 1, 3, and 4. Now it picked those from my tool library, and so I can go into my tool library and I can get those things, grab those things and work through those different ones. And so what if I don't have those set up, and what if I need to go in and do some of those things? How do I get to that? How do I go in and edit a tool? And so a couple of different ways that you can do it. You can come in here and go to your manage. You can manage your form tools, tool library, machine library, task manager, import, export, all that stuff. So we'll go to tool library and we go to this guy right here. Now it generated all that stuff from this. What it did was it pulled these out and it stuck them in here, so it duplicated them as it went. So like I said before, when you're building a first program, after you build this program, you now have a half 13 tap. You now have a weird drill, 10.8 millimeter drill. We'll change that in a second. We have an odd 14 millimeter spot drill. We'll change it as well. So again, if you don't have those, that's not a problem. You go into samples, you look for the operation of spot drilling, you pull a spot drill, and you go. Here I've got one, so I'm just going to take and probably already going to have a little bit hard time using that one just because it's already probably pulled up. So I can go into the edit of this tap, have 13 tap. I can go in and do all of my editing from it, save it, do whatever I want. This 10 millimeter or 10.8 millimeter drill, I'm going to edit it. And I'm going to go in, I'm going to change that to a metric, or an inch drill, sorry. And we're going to call it a 421 drill. So it's going to be a 2764s, and we'll just change that in the description, 2764s drill. And speed and feeds will probably be the same. That's moving. Everything else I'm okay with, especially on something like this. Hit OK. Do I want all of this stuff to catch up with it? Yeah. Okay. So you can do that. There I am. Now, oh my gosh, I got a exclamation point. What do I do? It's a great question. So what I need to do is I need to regenerate this particular operation, because as of now it's junk. It doesn't know what's going on. So if I right click and then I go to generate, it's going to fix it. If I go in and make some big major changes and I'm not sure about what's good and what's not anymore, if I do a Control G, I can regenerate all those modes or all those operations at the same time. So now that I have all that stuff set up, I can save again. So I'm up to 7 saves now. So version 7, revision 7. Alright, so I've got that almost saved. Alright, so what do I have left to do? I need to post code, and I need to create some type of setup sheet. Both of those will happen pretty fast. So I go up here, I'm going to create a setup. I've already said that it was 2525 earlier, no reason. And it's going to be sample, let's just say sample 6.8. Where I want to keep it, how I want to work it, what I want it to do, all of my personal preferences, sequence numbers, no sequence numbers, preload tools, no preload tools. All of those things are going to be in our post processor. We'll work on those things as we go. Right now we just want to kind of work on the ability to create some code. We're going to do a milling operation. We're going to go ahead and pick our machine now. It's a Haas. We can use UMC 750. That's got A and B axes. We can go down if we wanted to get super simple. We can do a pre and GK, so non-next gen control. We can preload tools or not preload tools. We can separate words and spaces. We can have an optional stop in there. We can have home position center. We can have sequence numbers, no sequence numbers. We can, you know, we got a lot of options here. So you got all these things that you can add into it. And so we can hit either OK from this point, or we can hit post. But what we want to do before we do that is we want to go ahead and hit this next operation page. As of now, it does not have anything selected, so it wouldn't create a program for us. So now we've got all of our stuff ready to go. Now also, if I wanted to take that mid pass out, I can take that mid pass out. If I wanted to leave it in, I leave it in. I can turn off and on all the things that I want, none of the things that I don't. Okay, so it's a little bit of a buffet here. I can reorder to minimize in my tool changes if I want to. So if I use tool 5 and then tool 8 and then tool 5 again and then tool 9 and then tool 5 again, it can run the tool 5 all at the same time. If that's something that's applicable, it may not always be applicable for you. So from here, if I want to, I can, that's something out of range. But what's crazy is that nothing told me that before. Let's go back and let's just change the machines. See if we still have that problem. Oh, I already have a program. Okay. So I've got my NC code here. So something was wrong in my machine setup. Again, I told you I just had one thrown together, not necessarily one that I have tweaked. I have some that I have tweaked, but that was not one of them. So here is my code. Prints out or starts out, opens up in WordPad. We've got 2525, misspelling of sample 6.8. It's telling me just some of the defaults that I've allowed it to do or it's done for me, but some of them I would not necessarily use. I'm a fan of G0 rather than G0 or G1. I get it, but that's just kind of how I grew up. Gives me a quick tool list, and then it gives me all of my information as to what's going to happen. I think it's an extremely long program. That's what you're going to have to get your mind wrapped around. A little over 2,000 lines, but it's doing everything for you, including some rotations of B and C axis. Now, so that can, depending on how parameters are set up on your machine on the Haas, it can be an issue or it could not be. So everything else looks pretty good. It's doing basically what we want. So we are doing a tool change. We're turning our spindle on. We're using G54. We're going. This is for our moving our table. We're rotating our B and C back to 0. We're going to turn the coolant on. We're going to move around with our face mill. It's tool 2. Tool 2 is here. H2 is here. We're going to go to 1.6255 or 1.625. That just drives me crazy. I like the nominal numbers there. It's going to preload tool 5, and so on our umbrella carousels we don't have that option of doing that. But we don't care. It's not going to hurt anything. It's not going to be in our way. The only place it's going to cause us a problem, so tool 5 is our next tool that runs. So here you have turn coolant off, optional stop, go to tool 5. The only time it can possibly cause a problem is if you're at the machine and you do, so say you're right here, and you type in T5 arrow down and you search for T5, it could possibly, actually it would find this T5 first. If you do not look at the program and hit cycle start from there, which would be foolish, you're going to have some problems because one, it's not going to turn the spindle on. I mean, unless you have, some parameters turned on. So you want to make sure that you need to look at the program before you hit cycle start. That's just an always and forever important thing to do. Okay, so here's our program. I could then go and do a file save as, whatever. I can open it and write in NC editor, whatever I want it to be. Okay, so that's our program. Program should be ready to post out to the machine. I don't think that this one would run flawlessly, but we'll get better as we go. Okay, so that's our code. So our NC program sitting here. It's got a little bit of information. Says work offset has not been specified. Using G54 as a work offset. That's fine. I chose 0, and it's going to default to 54. If I need to, I can go in and edit it, and let's see where I find my work offset at. And so my group 0 has those. Let's see. Maybe on the second page, I don't see work offset off the top of my head. I'm typically using 54, so I'm not really having too much of an issue with it. Don't need to change my retract distance. Not using G187, but I probably should. So I'm going to leave that one alone. And I thought that I had already put it in before into thought that I already put it in my setup here. I think I had it in as 0. Okay. So still going to be 54. And the program's still going to work fine. I'm going to do a quick save. Okay, we're saved. Last thing that I'm going to do, I can go back up here. So again, left to right, I'm under actions. I can go in and I can do these kind of my top 3 major ones. I can go down here and go to setup sheet, or I can go over here to setup sheet. Where do I want it to go to? It's going there. I've got one already called setup sheets. Populated over here on this other side. So it takes a picture of where my part is sitting at. So if I wanted it somewhere else, I need to put it in the position that I want it to show up in. Okay, so it's always going to pull from what is visible on the screen. So work offset is 0 or 54. My stock size is 2x2, 16th oversize on the thickness. My finished part is 2x2x1. Stock for 0, x0, y0, and the upper is, so lower corner, upper corner. Number of operations, 7. Total number of tools is 5. Tells me kind of how long this thing should take. It should take about 3 minutes to run. Seems like the one that we ran earlier was shorter than that. Gives our list of tools and then our list of operations, so they're not always going to be in the same pattern. So here we're going 1, 2, 3, 4, 5, and here we're going 2, 5, 5, 5, 1, 3. So we know that we're not always running in numeric order. Okay. So gives us cycle time for each individual tool, gives us all of our information for it. Remember, we went in and made this 3-inch shell mill. We used a 2-inch shell mill and just modified it. And so we put from the vendor of Kennametal. And so the more descriptive you get with that, the better things are going to be. Okay. All of our other stuff matches up really good. This is something I can print out and give to my operator. They're going to be set up, ready to go. So the more information that I can give to them, the better that everything goes for everybody else. I can do one more quick file save as, and just save, take care of that guy. I'm good to go from this point. I have everything that I need. I have a setup sheet, I have a drawing, I have a model, I have a semi-workable program. Like I said, this is a workable program, but I don't think that this is a great program. The idea is that as we get going, as we move along through this, that we'll be able to make some really slick programs that do the things that we need to do as we go. Okay, so I'm going to post this, and this will get you guys set up so that you can start creating some programs on your own. You've got some immersive stuff to do as well, but this will help get you moving along. All right, have a wonderful evening.